NCBM 0324, Section 1.2, Solving Linear Equations in One Variable, Part 3. Now let's get to some more really interesting ones. Let's look at some that may have those dreaded fractions. Example 3. Again, we're trying to solve. On Part A, we have 17 minus x plus 3 is equal to 15 minus a negative 6. Okay, we're looking out so far, no fractions. We have a parentheses on the right-hand side. So what we could do is get that taken away, get that applied. So I'm going to have 17 minus x plus 3 on the left equals 15. And we have a minus. So when we subtract a negative, that's the same thing as adding. So I'm going to end up with a plus 6 here. Then let's combine some like terms on each side. See, the 7 and the 3 on the left can be combined. And then, of course, the 15 and the 6 on the right-hand side. So 17 plus 3. Right, I'm not subtracting 3 here from the 17 because they're on the same side of the equal sign. So I'm just combining them. Then that x is going to equal 2. On the right-hand side, just combining terms. So 15 plus 3 is 21. Okay, then I'm going to move the 20 because that doesn't have a variable on it. I want to keep all my variables on the same side. So that leaves me with a negative x is equal to, and I subtracted the 20 because it was a positive 20 here. We undo that with subtraction. So 21 minus 20 gives me 1. It might be tempting to say, 1 is our answer, except in front of this x, I have this minus sign. See how that minus sign just kind of travels along with it so far? That minus is like saying negative 1 times x, and I want to get rid of any coefficient, any number in front of the variable. I just want the variable by itself. So like we did previously, I undo multiplication with division. I'm going to divide by negative 1. That's going to reduce down my coefficient. 1 times x is just x. 1 divided by negative 1 is a negative 1. And if we do the check, I take my negative 1, plug it into this x spot here. So it's a negative, and there's a minus in front. I'm going to go ahead and use parentheses to make sure I keep track of all my signs. So I have 17 minus a negative 1 plus 3. Does this equal 15 minus negative 6? And when we start to simplify using our order of operations, we're going to have 17 plus 1 plus 3. Does this equal 15 plus 6? Well, 17 plus 3 is 20, plus 1 is 21. I just did that a little nice there. 15 plus 6 is also 21. 21 equals 21. We have our solution. X is equal to negative 1. Now to part B. And we're finally facing those dreaded fractions. But it's okay. We have a way of clearing them out, of simplifying those fractions away. So on part B, we have 1 plus 3/5 a is equal to 8. So I can see the fraction here. And if I need to, I can even make the 1 into a fraction by putting it over 1. Any whole number we can make into a fraction by dividing it by 1. And the same thing with the 8. So in this case, my LCD, my least common denominator between the 1, the 5, and the 1 is going to be a 5. That's going to be the magic number that's going to make all of this fraction business go away. So here's how we're going to use that 5 now. Our instructions say to multiply by the LCD. More specifically, multiply both sides of the equation by the LCD. So I'm going to write times 5 on the left-hand side and also on the right-hand side. And when I multiply everything on the left side, think of that as inside parentheses as I wrote it. That means I'm going to have to multiply both the 1 and the 3/5 a by that 5. Well, times the 1 is pretty nice. It's just 5 times 1 is basically just 5. And if you're worrying about the bottom, 1 times 1 is 1. And what's 5 divided by 1? It's just 5. So we can leave it just as 5. Now to the fraction, 5 times 3 is 15. I'm multiplying straight across. 5 times 3 is 15. 1 times 5, in this case, is 5. Then I still have that a. And on the right-hand side, 8 times 5 is 40. And then 1 times 1, it's going to be on the 1 on the bottom, so we're okay. So multiplied by that LCD. And you may be wondering, there's still a fraction. But look at the fraction that's left over. What is 15 over 5? Well, that reduces down to a nice 3. So in reality, we have an equivalent equation. 5 plus 3a is equal to 40. But isn't that so much nicer to work with than the original one with the fraction in it? And then it just looks like one of the other equations we've been solving. So I'm going to move the 5 over. That gives me 3a is equal to 35. That's 3 times a, so I'm going to undo that with division. That reduces away to a 1 on the left side. 1 times a, simply a. 35 over 3. That's as far as that can go. And if we do the check, we can see that it does work out. Right? Multiplying 3/5 times the answer that we found ends up giving me, once reduced down to 7 plus the 1 equals 8. That's the other side also, so it matches up. So our answer is a equal to 35 over 3, right? So we may have seen that fraction in the beginning, wanted to skip this problem, but that LCD, right? Anytime you see a fraction and it's an equation, look for that LCD. It's going to make things a lot simpler.